Here we have a problem from the South Carolina 2017 math contest. And we're given a and b, where a is equal to the square root of 6 plus the square root of 6 plus the square root of 6 all nested. And this continues on infinitely. And b is equal to the square root of 9 minus the square root of 9 minus the square root of 9, where this continues on infinitely as well. And we're asked to find a times b. So let's jump into the solution. First, what we want to do is notice that a squared is equal to 6 plus a. We can see this because when we take the square of a, this outside square root goes away, but then we have 6 plus and then infinite square roots of 6 plus square root of 6 continuing on afterwards. But now we can solve this quadratic equation for a. So we'll have a squared minus a minus 6, which is equal to 0. But that means we have two solutions, one where a is equal to 3 and one where a is equal to negative 2. I do think this is pretty interesting that we get a negative 2 solution here for infinite positive nesting of radical roots. I think that's pretty interesting. So now let's work with b, and we'll use the same principle. When we square b, we notice that we get a 9 on the outside, and then we get a subtraction of infinite nesting of the square root of 9. But now we can solve this quadratic equation for b. So we have b squared plus b minus 9 is equal to 0. And here we're going to need to use the quadratic formula, so that's going to be minus 1 plus minus the square root of 1 minus 4 times 1 times negative 9, and this is all over 2a, which is just 2. So here we see that b is finally equal to negative 1 plus minus the square root of 37 over 2. But now we have our solutions for a and b. So here I'm going to draw a green box in, and this is where we're going to put our 4 solutions. We should have 4 combinations because we'll have the positive solution for a times the positive solution for b, the positive solution for a, the negative solution for b, the negative solution for a times the positive solution for b, and the negative solutions for both variables multiplied together as well. So let's do the positive one first. That'll give us 3 over 2 times the square root of 37 minus 1. That's the positive solutions from both multiplied together. That's 3 and negative 1 plus the square root of 37 over 2. We also have 3 over 2 times negative the square root of 37 minus 1. That's by minus 1 minus the square root of 37 over 2 and 3 up here. We also have 1 minus the square root of 37. That's by minus 2 times this whole thing here, but then the 2's cancel and the signs on each of these flip. So we'll have positive 1 and minus 37 for the positive solution of b. And then the negative solutions for both gives us 1 plus the square root of 37. So these are our 4 solutions for what a and b could be. And that's enough for now.